Perfect. And the last one, 100 choose 98 is the same as 100 choose 2. Start expanding the bigger one, 199, and then the 98s would cancel. You get 990 divided by 2, 4,950. So this little bit is a review because it's going to connect to what we're doing next. So we're reviewing this from grade 12. Remember Pascal's triangle. And remember that Pascal's triangle is just combinations. So, for example, if I take this row here, this is 4 choose 1, 4 choose 2, 4 choose, so close, here we go. So this is 4 choose 0, 4 choose 1, 4 choose 2, 4 choose 3, 4 choose 4. And you can always remember which choose one it is by the second number. So for example, here I have a 6. That's 6 choose 1. So then you would know this whole row is 6 choose 0, 6 choose 1, 6 choose 2, 6 choose 3, 6 choose 4, 6 choose 5, 6 choose 6. And then, okay, now in your formula booklet, you have this formula. Last year, you had this formula. And this formula shows up again. I'm going to take out my whiteout. Oh, that's what I'm missing. Sorry. I have to quickly create a whiteout pen because it's very important. Here we go. The whiteout pen. So, in your formula booklet now has NC1 like this and NCR like that instead of the bracket. So they changed it up like crazy when they changed the curriculum. Decided on a new formula. Now, I didn't even bother changing my notes because a new formula, old formula, makes really no difference. I'll change it as we go here. But this formula that you had in grade 12, on your formula sheet in grade 12, is right here in the IB formula. Okay? Things that the IB formula is nice is it tells you what n is. It shows you that n is the exponent. But it doesn't tell you explicitly the tk plus 1, that this would be term r plus 1. They do it a little bit indirectly because they tell you that term 2 has a 1. So they're kind of telling you that this is term r plus 1 from this hint. But you kind of have to know that in order to figure that out. So that's how you can remember that this is term r plus 1. So if you want to find term 7, man, I'll just erase this and change it to the new notation. Then term 7 would be 9 choose 6. And the r value would be 6. Well, that's another major change. Last year it was a k value. Now it's an r value. I think that's going to be okay. I think the weirdest one was in geometric sequences, where they changed term 1 from T1 to U1. Didn't you think that was like, why? Anyways, if you were finding the 7th term, each of these you could calculate separately, then multiply your numbers together, and you get a very nice big number as a result. this actually is perfectly looking at the board with eyes that are so focused, it's like, oh, what a good student. It's like, look, doesn't it look like it's just like paying attention the whole time? Right? As teachers, we really appreciate you. You look out while we're teaching, like, who's paying attention? This is like, I might have to borrow this for all my classes just from now on to give myself that self-confidence that I can keep going. Okay, so that'll make no sense whatsoever on the video. All right, find the term with a y to the 12 in the expansion of this. So again, we would go to our term formula. I get to use my eraser or whiteout. Actually, I'm going to add one more step before this. I would say I would look at my term r plus 1, and I don't know which term has the y to the 12. So temporarily, I'd say, well, I know it's going to have 9 choose r, and I know it's going to have 3x to the 9 minus r and negative 4y squared to the r. And the only hint that I have is that it's going to have a y to the 12. Some of these are more complicated and some of them are easier. This one I would consider an easier one because the only place there's a y is here. The 9 choose r is going to be a number. Even though we don't know what that number is, it's not going to affect the y. This term has x's but no y's, so it's not going to affect the y. The only place that we have y's are in that yellow box. And we have a y squared to the power of r. It's pretty obvious that r has to be 6 to get a y to the 12. So some of them are this easy. You just look at them, and I think there was one, was it on your lab? Like this? Yeah. There's one on your lab just a little while ago, and you could figure out, oh, it has to be 6. And then once you have that at 6, it's just a matter of putting those numbers in, multiplying them out, and there's the term that has a y to the 12. It also has an x cubed, but that doesn't matter. So again, this is a nice review because that formula is not hard. But if you don't remember what all the things stand for, and if you look on your IB sheet and it's written a little bit differently, that could be a little bit confusing. So this is just a good review of the binomial theorem from grade 12. Oh, these were the hardest ones in grade 12. What is a constant term? Yeah, I like the looks. The looks are, right? This is one, she knows, but she's not going to say. She just got that grin on her face, like, I remember, but I won't let anybody else know. This would be no x's, or you could think of it as having an x to the 0, because the x to the 0 would be 1, and it would all cancel out. I just want to do this question. Okay. So, if I had this, yeah, I'm going to, I don't care what I did in the past. It's all gone now. Oh no. Better not forget now how to do this. Okay. So if I put this into the formula, so again, you don't have this part, but you could write this down. We would have 14 choose r. You would have 3x squared to the 14 minus r. And you would have negative 1 over 2 to the x to the 5 to the r. And now this is more complicated than the last one because we want all the x's to cancel out. But there's x's in the first term and there's x's in the second term. In fact, if you like to do things algebraically, we can solve this one algebraically. And what we do is we say, I know that I need an x to the 0. And I ignore the numbers in front, because they really don't matter right now. And on this side, I'm going to have some x's that are in my numerator and some x's that are in my denominator. Does it make sense that whatever r is, this x squared to that exponent is going to all have x's in my numerator? And this x to the 5 to the exponent of r is going to have my x's in my denominator. And notice I ignored the 2. I also ignored the 3, because those are numbers in front, and that wasn't part of the hint. The only thing they gave us as a hint is that we need an x to the 0. Now, there are some people who just go, I know that r is a whole number. This can't be very hard. I think I can figure it out. So they go, I think r is 4. If r is 4, do you see that I would have x to the 20 on top? And I would, oh, shoot. That was totally a mistake. I wanted to guess one that was wrong. But sometimes you get lucky and you guess one that's right. So I chose r as 4 and it works. But usually what happens is you choose something. Let's say I chose r as 3. If I chose r as 3, can you see that you would have x to the 22 on the top, and you would have had x to the 15 on the bottom, and it wouldn't work. You'd be left with x to the 7. And you'd be like, ooh, I need more x's to cancel out, so it's pretty obvious that r has to be bigger than 3. And then you'd be like, oh, let's try 4. And it would work. So there are some people who just like to do a little mental math for figuring it out, because it's not hard. There are some people who love algebra. And those that love algebra say, I would like to figure this out by using my algebra skills, right? What is on the top here? I have x to the 28 minus 2r. What do I have on the bottom? I have x to the 5r. That's my exponent rules. A power to a power, you multiply. And then I have another exponent rule that says, if I have a power divided by a power, what can I do to the exponents? I can subtract the exponents. So then I would get x to the 28 minus 2r minus another 5r would be minus 7r. And once you get to this stage, if the bases are the same, the exponents would have to be the same. So then we could just go from here and say, well, it's obvious then that 0 has to equal 28 minus 7r, add 7r to both sides, divide by 7, and I get r equals 4. That's an algebraic way of finding it, okay? Most of you are probably good at mental math already. You'd be like, I think I could do the mental math. It wouldn't take me very long to find out what works. Now, all we did to this point is find out that r was 4. We should reread the question. It says find the constant term. So now we would actually have to find r is 4. We're finding term 5. It was, I have to go up, 14. Choose 4. I should really have it memorized. 3x squared and 1 over, oh my goodness, 2x 5. Is it negative? And this will be to the 4, and this will be to the 10. 14 minus 4. And now we could go to our calculator and calculate these things. So 14 choose 4 is 1001. 3 to the exponent of 10. A negative to the power of 4 will be positive. 2 to the power of 4 will be 16. And nicely, all of our x's cancel out. We have 1,001 times 5490 divided by 16. 3690562.5 as an exact answer in the end. And this is the constant term because it has no x's. Now, so this is one topic that is from grade 12 that's going to be on your IB exam. And I would say in the past, I would say this is a topic, for whatever reason, the IB exam likes to get creative, okay? And when I say creative, you should get scared because that means that they try to make these ones hard. So we have to know how to do these basic ones. They wouldn't even consider this one a hard question. They would say this is regular. What would happen if we start messing around with numbers and different things? So you'll see when we get closer to the exam, you'll see what some of those questions look like. On here, do I have one of them? Trying to see. Yeah, like 6. Yeah, when we get to number 6, this one is really easy. But do you remember how to tell how many terms there are? It's always one more than the exponent. And then if you wanted an x to the 12 in this one, okay, let's look at this. You're going to have 6 choose r, x cubed to the 6 minus r, negative 3x to the r. All those x's are going to be in your numerator. You want an x to the 12. Look at it, do some mental math. Tell me what r is in your head. Well, don't say it out loud, because that will influence somebody else. But can you figure out what r is without doing any of the algebra? Did you get... at this moment, you should either be able to tell me what r is, or tell me r is for sure not 4, because I tried 4 and it did not work, right? So sometimes finding something that doesn't work helps you find what works. Did you get that r had to be 3? Because if you have a 3 here, you'd have 3 x's. A 3 here would give you 9 x's. Together, that would give you 12 x's. So r is equal to 3. And then it's just a matter of plugging things into the formula. There we go. I'm not even going to get you to write anything else. Save time. I'm sure you could write that. That's the answer. If you want to try this one later on your own, perfect. You just leave it like that. But this is a relatively straightforward question. But they like to do stuff like this. Get a little bit creative. Mix up the formula a little bit. So I guess if this question came up this year, they would have this. And then they're asking, can you see from the equation that n has to be 10? And then write down the values of a and b in terms of p and or q. This is easier than you think. But sometimes they ask easy questions in what appears to be a hard way. Like, write down a and b in terms of p and q. First of all, let's revisit what in terms of means. It means that you need to write A equals, and on this side you can have P's and Q's. And you need to write B equals, and on this side you have to have P's and Q's. So when something says in terms of x, that means on the right-hand side of your equation, you're going to have x and other numbers as well. If it says in terms of f of x, that means on the right side of your equation, you're going to have function notation with f of x and other things as well. So this says in terms of p and q, and it's really easy. Can you see that the a value is p and the b value is 2q? That's all. But when you write that down, it seems too easy, so you start to second guess yourself. And the IB exam will do that to you. They will give you some questions that seem too easy, and like you're almost offended. What, did you think I was in grade 2? They give you like, what is 1 plus 1? You're like, really? And this is where 7 marks? Sometimes they do stuff like that. And then the next time, they give you a question that is so hard you think it's unfair, and they're like, yeah, we'll do that as well. So you get the widest range of questions, from super easy to super hard. This one was super easy, and written to make it sound like it was going to be super hard. Okay? Then if you wanted to find the 6th term, I'm going to change to new notation. Here we go. Straightforward. So this is a good question of what does it look like when a question looks like it's going to be hard, but actually isn't? And this is a good question of a question that is hard, and it is a little bit harder than normal. So it's different in that nowhere, I don't think anywhere in grade 12 did they ever get you to solve for the exponent. And it's really not that much more difficult. But now when we write out our formula, I don't know n, but I know that r is 5. And I would have x cubed to the n minus 5 and negative 4 over x to the 5. And once you write out the formula part, you realize that this is very similar to the ones when we didn't know r. And you probably can do some mental math. What would n have to be to give you an x to the 16? You know that there's going to be an x to the 5 on the bottom. And you know on the top, there's going to be an x cubed to the n minus 5. And I want an n, I want to have x to the 16. Does it make sense that the top has to be x to the 21 if you have an x to the 5 on the bottom? And if the top has to be a 21, what does that have to equal? 7. If that has to equal 7, then n has to equal 12. So it's just a little bit different. And they get even more creative than this. One of the, I'm actually, this may sound bad, but I'm really excited that you guys are writing an exam. The process of getting ready for this big, huge IB exam, something that you haven't done in most of your, because of COVID, you haven't like really prepared for an exam. It's getting ready for an exam is a large undertaking. It's a lot of fun because you get to do a lot of math and you get to relearn all the stuff that you've learned over the years, and you actually get to learn it really, really well in preparation for that exam. And to me, that's an exciting thing. To you, it might be like, that's the last thing that I think would be exciting, but okay, I feel good. getting that affirmation. No, but it's gonna be good. And we're going to see as we do, one of the things that we do to get ready for the exam is that we do a lot of old exam questions. So you're going to see some of the tricky questions that have come up, and you're gonna be like, you're gonna come in and ask for like, what did you do in this one? And it is a very fun process. So I'm really looking forward to that. Anyways, I won't put anything, oh, yeah, find the value of n. We did that. Okay. Here's another way that they get creative. Consider the expansion of this. The constant term is 16,128. What could k possibly be? So much. So, question. It's blinking red, meaning the batteries are about to die. So we will switch it to this one and hope this one works. Luckily it's Halloween, because I always think this mic looks stupid. All right, we'll see. Hopefully this one works. Thank you for noticing the little red light was going. So we need a constant term. In other words, all the x's have to go away. We have an exponent of 8. So we can go to our formula and say we know that n is 8. We don't know what r is. We know that, I like this one. Okay. Do you see we have this extra x squared in front? Oh, it's just enough to make some people just want to quit altogether. Okay? But think about it. If we want a constant term in the end to be this, does it make sense that if we look just at the expansion part, the hint is it would have to have an x to the squared on the bottom? Because then when you multiply that x squared on the bottom by the x squared, all the x's would cancel out. So they just add a little bit to see if that little bit can throw you completely off, right? And if it throws you completely off at the beginning of an 8-mark question, that can be very disheartening. It's not like, you don't feel bad if you get like almost through the question and then something right at the end throws you off. It makes you feel very bad when you get thrown off right at the beginning and you don't know where to start. And they will put questions like that on your exam. I was going to say purposely, yeah, on purpose, to see, can you handle something a little bit different? And in this case, that x squared in front tells us that if I'm in the expansion of this, I need to have an x squared on the bottom. Now, I would have a choose r, my, sorry, didn't want to change colors, 3x squared to the 8 minus r, and then a k over x to the r. And we need to problem solve to first find what that r would be. Again, we want to have an x squared on the bottom. Do you want to try to do it in mental math? Or do you want to do it algebraic? What are you feeling? Algebra? Okay. So I want a 1 over x squared. Here, what do I have in my numerator? I'm going to have an x squared to the 8 minus r, those will be my x's in my numerator. And in my denominator, I'm going to have an x to the r. This is going to give me x to the 16 minus 2r over x to the r, which if I subtract the exponents, will give me x to the 16 minus 3r. What's another way you can write 1 over x squared? X negative 2. Excellent. And now, if you get, algebraically, if you get both sides with a base of x, then those exponents have to be the same. So we would get negative 2 is equal to 16 minus 3r. 3r equals 18. R is equal to 6. So we first found r, and now we know, okay? Does everybody get that? I'm going to scroll back up. You're good? Now, all we need to do is plug in r is 6, so we have 8, choose 6, 3x squared to the 8 minus 6 over k over x to the 6 times by an x squared. We can put that x squared in front. It has to equal 16128. Does that make sense? So if I figure out everything, 16128 equals, I have the x squared, 8 choose 6, I think that's 28. 3 squared will be 9x to the 4. And here I will have k to the 6 and x to the 6. Can you see that your x's successfully all cancel out? That's a feel-good moment. And then if I get the k to the 6 all by itself on the right-hand side, do you see that I would have to divide by 9, and 9 times 28? So I go to my calculator. 16128 divided by 9 times 28. I get 64. How do you get rid of a power of 6? 6th root it. I love those TH words in that. So if you 6th root both sides, you will get close plus or minus 2. Any even power is going to be plus or minus. So then you feel like you did all well right at the end, and then they go and add a plus or minus with a 6th root on both sides. This is a good example of taking it to another level, throwing that x squared in front. It seems like they'd like to do that a lot. Just think about, well, what that would do to everything that was in your original equation. Do you remember the way to expand things completely? Using Pascal's triangle? Right, because there's going to be 5 terms. This is the coefficients with 5 terms, and they're going to match up with 1, 4, 6, 4, And then your powers of your first one start with x to the 4 and go down by 1 each time until there's none left. And the other ones start with 0 and go up by 1 each time. Simplified, that's what you would get in the end. Now technically, you could have used the formula 5 times to find each term separately. But the way that your formula sheet has it, it lets you just sort of write it out as you're going along. Now, you figured this out in part A. In part B, they say, take your answer in part A and multiply it by 3x plus 4. You could multiply the whole thing out and simplify it. What it means is that I would have 3x plus 4 in front of this whole thing. And how do you distribute if you have all of this? Well, the 3x, can you see that the 3x, and I'll draw this in blue arrows, would multiply by every term in here. And then the 4 would also multiply by every term in here. If I take out my purple pen, I'm like, do I need to do them all? No. I'm just worried about the ones that have x cubed in them. Which one from the 3x gives me an x cubed as if I would multiply by the 24? And which one from the 4 would give me an x cubed? So really, all I have to think about is the 24x squared times 3x, which is 72x cubed, and the 4 times the negative 8, negative 30, to get 40x cubed in total. Does it make sense that you wouldn't have to do all the multiplication? Just the purple arrows in the end. And that's the last question on this booklet, right? Okay, I'm going to end the video here.